Welcome to this session. So today we just want to look at this question quickly. So we've been given a silver nitrate solution which is added to 25 ml of 0.5 molar potassium chloride solution until no more precipitate is formed. So what does this mean? We are reacting silver nitrate and potassium chloride to form the product of which we expect to have the precipitate and other product. So they are saying write the balanced equation for this reaction between silver nitrate and potassium chloride, include the state symbols. So first of all, we should understand that the reaction between two soluble salts, silver nitrate and potassium chloride, these are soluble salts, right? These are soluble salts. So when two soluble salts react, okay, when two soluble salts react, what you expect to produce is an insoluble salt. So we say soluble salt plus soluble salt, okay? What you produce is one insoluble salt plus one soluble salt. This type of a reaction is known as double decomposition. Double decomposition reaction, or in other words, it's just the same as precipitation reaction. This is the case where the precipitate is formed. So now, what do we have in the context of now? So we have silver nitrate. So silver nitrate, let me use a different ink. Silver nitrate. So silver nitrate is a soluble salt, so the state is aqueous, plus potassium chloride. This one also is a soluble salt. What you produce is one insoluble salt. So in this case, the potassium replaces or displaces where silver is, okay, because it is too reactive. So what you are going to have is silver chloride as a soluble salt plus now the other product we are going to have is potassium nitrate, which is a soluble salt. So this is the product, these are the two products that we are going to have. This is the precipitate, the silver chloride. So this precipitate, this is the precipitate which was formed. Okay, so now we need to counter check after writing is the equation balanced. Well, if you look at the equation, this equation is balanced because we have one silver, one nitrate, one nitrogen, oxygen 3, potassium 1, chlorine 1. So this reaction is balanced. Okay, by balancing we mean the number of atoms on the reactant side must be equal to the number of atoms on the product side. So that's what we mean by balanced equation. So you need to counter check after writing. So this is your A. Your B, they are saying calculate or what mass of silver chloride will be formed. So now to get the mass of the silver chloride that will be formed, in other words, from the reactants that we are going to produce certain mass of silver chloride. So you need to go back to the question and check what information do I have. Well, we've got the volume and the concentration of potassium chloride. So we have the volume and the concentration of potassium chloride. So from the volume and the concentration, what can we find? We can determine the number of moles. So if you have the volume, so the volume of potassium chloride is 25 ml. So you need to convert this to liters, so it will be 0.025 liters. And then we also have the concentration is 0.5 molar. So this molar is the same as moles per liter. So how do we find the number of moles? So we can find the number of moles of potassium chloride, which is equal to concentration times volume. So what's the concentration? The concentration is 0.5 mole per liter times the volume is 0.25 0.025. Remember, the volume, whenever you are using this formula, the volume must be converted to liters or decimeter cubed. So what are we going to have here? We are going to have 0.0125 moles. So remember that the liter and this liter cancels out. So now we have this number of moles. So from the number of moles of potassium chloride, we can find the number of moles of silver chloride, which will convert to mass once we find its moles. So how do we go there? We are going to use what we are calling as the mole ratio. So how does the mole ratio works? The mole ratio is simply mean what's the coefficient in the balanced equation of these two reactant and product that we have. So for potassium chloride, the coefficient is 1. The silver chloride, the coefficient is 1. So if the mole ratio is 1 to 1, it means the moles of potassium chloride that we have there will be equal to the moles of the silver chloride that will be produced. In this case, the moles that we found was 0.0125 liters. So we can easily convert that to volume, to mass. So what are we going to do? We know to say the number of moles is equal to mass over molar mass. So how do we find the mass? Therefore, the mass is equal to the number of moles times the mixture, which is the molar mass. So in this case, the number of moles of silver chloride we have found is 0.0125. Oh, sorry, I said moles here, not liters. So moles times the molar mass of silver chloride, if you calculate, you find it is 143. So what will be after multiplying that? What are we going to have? So you can pause and do the calculation. Therefore, the mass will be equal to 1.7. Let me check again. Let me punch quickly. So it will be 0.0125 times 143. I'm getting 1.79. So the mass that you expect to produce from that volume of potassium chloride that we have is 1.79 grams. Remember, if you want to join in Chito Minds Academy, especially for the pre-university classes, you can always contact me on this number. Remember, we are offering all courses that include mathematics, chemistry, physics, and biology. Bye for now.